Okay, so I'm going to share some information with you about significant figures and uncertainty. A lot of this I expect that many of you have already had some experience with, so hopefully a lot of it will be review. And this is the kind of subject that I will agree is not the most terribly exciting stuff in the world, but you kind of have to get the rules under your belt so that then you can go on and do more interesting and fun experiments. Okay, so what does significant figures really mean? Well, it means that in any scientific document, which would include a lab report like you might do in a lab you're taking, then when you write numbers down, you're not going to just write them down any old way. You're going to make sure and write it down so that the figures you're showing are all good. They're all valid. So, and then when you do operations on them, there are certain rules you got to follow. Like say this example here, okay, that's on the board. Let's say somebody were to take this number 22.22 divided by 1.70, okay? So you can put that in your calculator. Now let's assume that whoever wrote these numbers intended to write them with those significant figures. Those are all supposed to be significant figures, okay? So let's say you divide those, you do a division in your calculator, and you'll get 13.0705, and then a whole bunch of other stuff that I didn't bother to write down. You'll get a whole bunch of figures after that, okay? Well, it's nice that the calculator gives you those, but they're not all good. What you would do in this case is you would take all that and round it off to three significant figures. So that would leave you with 13.1, okay? Notice it said 0.07 there, and it would round off to 13.1, okay? Why did I say three significant figures? Well, if you look at the numbers that went into it, the first one had four significant figures. The second one had three significant figures. So when you divide and multiply, your answer can only have as many figures as the least number of figures that went into it. Okay, that's the rule on that. So that's fairly logical, right? Okay. Now, one thing you might wonder about is this one here, 1.70. Now, you might be tempted to look at that and say, well, why bother to write that zero? It's just zero. Okay, it doesn't matter. Well, it actually does matter. If somebody bothered in a scientific document to write it this way, they intended it. You can assume they intended it. And what they meant was that that zero really is zero and not something else. Let's say, as an example, I were to measure something like, say, let's say I was going to measure the size of this box here, okay? Here's a cardboard box, and I've got a ruler, and I'm going to measure how wide it is, okay? So you might not be able to see the numbers, but that's okay. So I'd say I'm going to measure how wide it is with this ruler, and when I do that, I get 28 centimeters, okay? Now let's say when I was looking at the little marks in the ruler and lining them up, I really got it exactly 28.0. It's not 28.1. It's not 27.9. It really was 28, okay? So that's why you bother to write the 0.0, because I can measure it to 1/10 of a centimeter with that ruler, okay? We'll get more into that later. I can measure it to 1/10 of a centimeter, and it really was zero, not something else, okay? If I was to erase the zero, I would be saying, I know I've got 28, but in the tenths place, I don't know what it is. It could be anything. But if I bother to write the zero, that's saying, yeah, I'm asserting that that is actually zero and not something else. So that's the idea there. So sometimes you do include zeros that trail off. Okay. Okay. Now another example. Let's say you took a couple of numbers and added them, which is what I've got over here. All right. Okay. The rules are a little different there. So hopefully you can see that. Let me make that. Sometimes hard to see decimal points. So I wrote 123.4 plus 1.23. Now we're adding, we're not dividing. Okay, the answer I get is 124.63, okay? But the 3 is not valid, so I rounded it to 124.6. Why is it not valid? Well, because I have a 3 in that decimal place, but in the other number, I didn't have a 3 in that decimal place. Therefore, something I don't know, something unknown, plus 3 is still something unknown, okay? So I can't put that 3 there, so we just have to lose that decimal place, all right? So with addition and subtraction, you actually stop at the first decimal place that has common numbers in it. In other words, you've got a significant figure in every number you add together. So you can have a significant figure in the answer for that decimal place, okay? If they don't match up, then you just can't use anything like this, okay? Now, here's a common mistake that you'll want to try to avoid. What a lot of people do, mistakenly, when they're adding or subtracting, is they might look at these two numbers and then round the answer to three significant figures, because this one only had 3 significant figures, okay? That's what you do for multiplying and dividing, okay? You do not do it for addition and subtraction, all right? So it might look a little funny, it might look a little odd that you can get an answer that actually has more significant figures than one of the numbers that went into it. But when you're adding and subtracting, that's legal, that can happen, all right? So the rule that applies to division and multiplication, where you take the least number of significant figures of the 2 factors that went into it, people have a way of getting that stuck in their heads because it's logical, it's easy to remember, and then applying it to addition, but it doesn't work on addition. You have to just look at the